Hello, in this lecture we will find out the area of the green shape in three different methods. In the drawing we have rectangle ABCD. We know that AE equals to ED. We also know that EB equals to 7 units and BF equals to 9 units. And we also know that angle ABE equals to theta, and also angle EBF equals to theta. And we want to find out the area of the green shape. Okay, so we'll start with the first method. So in the first method, we will extend line segment BF, line segment BE, and line segment CD. We will extend them until they intersect with each other. Okay, so here we will extend line segment BE. And we will also extend side CD or line segment CD until they intersect with each other, and we will define the intersection point, the point they meet, point P. So the touching point between them, this point, or the intersection point between them, is defined as point P. And we know that all the angles inside a rectangle are right angles. Therefore, this angle is equal to 90 degrees. This angle also equals to 90 degrees. And this angle also equals to 90 degrees. So actually CD is one side of rectangle ABCD, therefore it is absolutely a straight line. So CD is a straight line, and we extended CD, the straight line CD, by a straight line. Therefore, CP will be still a straight line. Okay, CP is a straight line. I will write it down. CP is a straight line. Line segment CP is a straight line. And we also have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? The sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so I will read rule number 1 again. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. And we have already proved that line segment CP is a straight line. Line segment CP is a straight line. So if we focus on this side of the straight line CP at point D, the sum of the angles must be equal to 180 degrees according to rule number 1. Okay, the sum of the angles on this side of the straight line CP at this point D must be equal to 180 degrees according to rule number 1. So which angles we have on this side of the straight line CP at point D? We have this angle that we will define as angle X plus this angle that is a right angle. The sum of those two angles must be equal to 180 degrees according to rule number 1. So angle X plus 90 degrees must be equal to 180 degrees according to rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So here we will subtract 90 degrees from this equation and we will get that angle X equals to 180 degrees minus 90 degrees is equal to 90 degrees. So we found out that angle X is a right angle, that is to say it equals to 90 degrees, so we can substitute angle X by a right angle we know that the opposite sides of a rectangle, they are parallel to each other. That is to say AB is parallel to CD and CP is actually the extended CD. With extended CD we got, by straight line we got CP. Therefore, if AB is parallel to CD, then AB will be also parallel to CP. Okay, so we can write down that AB is parallel to CP because CP is one straight line. Therefore, if AB is parallel to part of the straight line CP, then it must be also parallel to all the straight line CP. Okay, so you can write down that AB is parallel to CP. AB is parallel to CP, and we have also rule number 2 that states that according to rule number 2, alternating angles between parallel lines are equal to each other. So I read rule number 2 again. According to rule number 2, alternating angles between parallel lines are equal to each other. So we know that AB is parallel to CP. We know that AB is parallel to CP. And actually, those two angles are actually alternating angles. And those two alternating angles are located between the parallel lines AB and CP. Okay? Therefore, they are equal to each other according to rule number 2 that states that alternating angles that are located between parallel lines are equal to each other. AB is parallel to CP, and those two alternating angles are located between AB and CP, therefore they are equal to each other. That is to say, angle ABE, this angle equals to angle EPD, this angle. I repeat again, angle ABE equals to angle EPD according to rule number 2. But we know that angle ABE, this angle, equals to theta. It is given us in the question. This angle equals to theta. So angle ABE equals to theta according to what is given us in the question. So from this equality we will conclude that angle EPD also equals to theta. Angle EPD also equals to theta. So we can write here that angle EPD, this angle, equals to theta. In the next step, we will prove that those two right triangles can go into each other. So we will focus on the right triangle, triangle ABE, the green right triangle, triangle ABE. And the right triangle, triangle EPD, this triangle. And we will prove that they can go into each other. First of all, we just right now proved that those two angles, they are equal to each other. That is to say, angle ABE equals to angle EPD. And both those two angles, they are equal to theta. So, I'll repeat again. Angle ABE equals to angle EPD, and they are both equal to theta. Those two angles, they are also equal to each other. They are both right angles. So angle BAE of the green triangle, this angle equals to angle PDE, this angle, and both those two angles are equal to 90 degrees, they are right angles. So I'll repeat again, angle PAE equals to angle PDE, they are both right angles, they are equal to 90 degrees. Those two angles, they are vertex angles, and we have a rule that vertex angles are equal to each other. Angle AEB in the green triangle equals to angle PED in this triangle, PED. According to the rule that vertex angles are equal to each other. I'll repeat again. Angle AEB equals to angle PED, and they are equal to each other according to the rule that vertex angles are equal to each other. So I actually proved that all three angles in triangle BAE congruent to all three angles in triangle PEPD, and we also know that AE equals to ED, AE equals to ED according to what is given us in the question. It is given us in the question that AE equals to ED. Okay, AE equals to ED according to what is given us in the question. I repeat again. AE equals to ED, it is given us in the question. We actually proved that those two triangles can go into each other according to angle side angle rule. So I write it down. We proved that the green triangle BAE congruent to triangle PED. We proved that the green triangle BAB congruent, this is the sign of congruent, to triangle PED according to angle side angle rule. Again, they can go into each other according to angle side angle rule. So what is angle side angle rule? Actually, angle side angle rule states that if two angles and the side that included between those two angles congruent correspondingly to two angles and the side that included between those two angles this we should add in one triangle in another triangle then the triangles congruent to each other according to angle side angle rule. So I'll read angle side angle rule again. Angle side angle rule states that if two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included between those two angles in another triangle, then the triangles congruent to each other according to angle side angle rule. And we actually proved that here those two angles and also the side that included between those two angles in the green triangle congruent to those two angles and the side that included between those two angles in the other triangle. Therefore, we proved that those two angles congruent to each other according to angle side angle rule. Actually, we proved more than is needed because we proved that all three angles congruent. Okay, in those two triangles. Okay, so from the fact that the green triangle ABE congruent to triangle PED, we'll conclude that BE equals to EP. We'll conclude that side BE of the green triangle is equal to side EP of triangle EPD. I'll repeat again. Side BE of triangle BEP equals to side EP of triangle EPD. According to the rule, the corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore those two corresponding sides will be equal to each other. Okay? But it is given us in the question that BE equals to 7 units. Here, BE equals to 7 units. So we can write here that BE equals to 7 units, and from this equality we will conclude that EP also equals to 7 units. EP also equals to 7 units. So here EP also equals to 7 units. And because of the fact, first of all, we will define the area of the green shape BEFD, the area of the green quadrilateral BEFD, the area of the green triangle quadrilateral BEFD, SY. Okay, the area of this quadrilateral BEFD equals to Y according to our definition. And if we define the area of the green triangle ABE as X, then because of the fact that we have already proved that those two triangles can go into each other, they also have the same area. That is to say, if the area of the green triangle ABE equals to Y, then the area of the congruent triangle EPD will be also equals to X. So if the area of triangle ABE equals to X, then the area of the congruent triangle EPD will be also equals to X. So actually the area of the green shape equals to X plus Y. I'll repeat again. The area of the green shape this is the sign for the area of the green shape equals to x plus y. You can see it, the area of the green shape equals to x plus y. But we see that the area of triangle BPF also equals to x plus y. The area of triangle BPF also equals to x plus y. So we can find the area of triangle BPF that equals to x plus y. In this way we will find the area of the green shape, because the area of the green shape also equals to x plus y. So we will find the area of triangle BPF, and in this way we will find the area of the green shape. Okay, because they are equal to each other, they are both equal to x plus y. Okay. First of all, we have already found out that the base BP of triangle BPF equals to 7 plus 7, that is to say, it equals to 14 units. And we have a new wall. According to the new wall, that is actually wall number 3. According to the wall number 3, I will remind you that triangle BPF is a right triangle because of the fact that those two angles, they are equal to each other. They are both equal to theta. Therefore, triangle BPF is an isosceles triangle. Okay, I will write it down. Triangle BPF is an isosceles triangle. Because it has two angles that they are equal to each other, they are both equal to theta. So this triangle is an isosceles triangle, and we have rule number 3 that relates to isosceles triangles. According to rule number 3, and we know that the base of the isosceles triangle BPF is BP. The base is BP, and we have rule number 3 that states that the median to the base, in an isosceles triangle is perpendicular to the base. repeat on all number 3 again. According to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have an isosceles triangle if triangle ABC is an isosceles triangle, so here this triangle ABC, is an isosceles triangle. Why? Because it has two angles that are equal to each other. They are both equal to theta. And here BC is the base of triangle ABC. So if we draw a median to the base, that is to say, if we draw median to BC from point A, as you have already know, the median bisects the base BC. That is to say, it divides it to two equal parts. So if the touching point between the median and the base BC is point O, then according to the definition of a median, the median AO bisects the base BC into two equal parts. That is to say, if BO equals to X units, then OC will be also equal to X units, okay? So we have here triangle ABC that is an isosceles triangle because it has two angles that are equal to each other, and we have the median AO that bisects the median AO to the base that bisect the base BC into two equal parts. That is to say, BO equals to OC equals to X. According to rule number 3, the median AO is perpendicular to the base BC. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so whenever we have an isosceles triangle and we draw median to the base, then that median will be perpendicular to that base. In this case, the median AO is perpendicular to the base BC. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Why? Because the median to the base is perpendicular to the base. The median AO to the base BC is perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. And we will implement rule number 3 in our drawing. In our drawing, we know that triangle BPF is an isosceles triangle. Why? Because it has two angles that are equal to each other. Though both those two angles, they are both equal to theta. Therefore, triangle BPF is an isosceles triangle. And the base of this isosceles triangle, triangle BPF, is BP. So according to rule number 3, the median to the base is perpendicular to the base. So if we draw from point F median to the base, it will be perpendicular to the base. So in from point F, we will draw the median to the base BP. This median, the median FE, that according to its definition, the median actually bisects the base BP into two equal parts. That is to say, BE equals to EP equals to 7 units. Okay, the median FE bisects the base BP into two equal parts, but according to rule number 3, this median to the base of the isosceles triangle BPF, it is also perpendicular to the base BP. So the median EF is perpendicular to the base BP. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, according to rule number 3, the median FE is perpendicular to the base BP of the isosceles triangle BPF. That is to say, those two angles are right angles. Okay? So, because of the fact that this angle is a right angle, then triangle BEF is a right triangle, so we can implement the Pythagoras theorem in the right triangle BEF. So if we focus on the right triangle BEF, in the right triangle BEF, according to the Pythagoras theorem that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, in the right green triangle BEF, this right green triangle, the square of the hypotenuse in the right triangle BEF, it is actually is located in front of the right angle, in front of this angle, that is a right angle, that is to say it is BF. So the square of the hypotenuse is BF square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BE square plus EF square. So, I will repeat again. In the right main triangle BEF, according to the Pythagoras theorem that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, it means that BF square equals to BE square plus EF square. It is given us in the question that BF equals to 9. If BF equals to 9, then BF square is 9 square. 9 square is 81. 81 equals to BE square. It is given us in the question that BE equals to 7 units. So BE square is 7 square. 7 square is 49 plus EF square. So in conclusion, we found out that 89 equals to 81. 81 equals to 49 plus EF squared. We will subtract from this equation number 1, 49, and we will get that 81 minus 49 is 32. So 32 equals to EF squared. We will take a root from this equation number 1, and we will get that EF equals to the square root of 32. But we know that 32 is 16 times 2, so I will write it down. 16 times 2. And we also know that the square root of 16 is 4. So in conclusion, we found out that EF equals to 4 times square root of 2 units. So EF equals to 4 times square root of 2 units. We can write here that EF equals to 4 times square root of 2 units. So, and we know that the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of the triangle BPF equals to the base of the triangle times the height to the base over 2. The area of triangle BPF equals to the base of the triangle times the height to the base over 2. Okay? So actually, the area of triangle BPF equals to the base. The base is BP times the height to the base is EF over 2. I'll repeat again, according to equation number 2, the area of triangle BPF equals to the BP times EF over 2. BP is equals to 7 plus 7. That is to say, BP equals to 14 units. Times EF. We have already found out that EF equals to 4 times square root of 2 units over 2. So, in conclusion, we found out that the area of triangle BPF, that is actually also the area of the green shape, equals to 14 times 4 times square root over 2. 14 over 2 is 7, so I'll write it down. So the area of triangle BPF equals to 7 times 4 times square root of 2. 7 times 4 is 28. So in conclusion, we found out that the area of triangle BPF, that is also the area of the green shape, equals to 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. I repeat again. We actually found out that the area of triangle BPF, that is also the area of the green shape, equals to either 28 times square root of 2 square units, or in terms of numbers, the area of the green shape equals to 39.6 square units. Okay, so we finished with the first method. So we will continue in the second method. We continue to the second method. We'll find out the area of the green shape according to the second method. Here, theta. So we'll continue with the second method. Actually, we know that in a rectangle, the opposite sides of a rectangle are parallel to each other. That is to say, AB is parallel to CD. I write it down. AB is parallel to CD because of the fact that the opposite sides of a rectangle are parallel to each other, and ABCD is a rectangle. That is to say, AB is parallel to CD, but CF is part of CD. CF is part of CD. So if AB is parallel to CD, it will be also parallel to CF. Okay, so AB also parallel to CF. And I will mention again the rule that alternating angles between parallel lines are equal to each other. This angle is angle theta plus theta, that is to say it equals to 2 theta, and those two angles, they are alternating angles. This angle that equals to 2 theta, it is alternating angle, and this angle is also alternating angle. And we have the rule that alternating angles that are located between parallel lines are equal to each other. Those two alternating angles are located between the parallel lines AB and CD, AB and or CF, okay, AB and CF. Those two alternating angles are located between the parallel lines AB and CF, therefore they are equal to each other. So this angle equals to 2 theta. Therefore this angle will be also equal to 2 theta, according to the rule that alternating angles that are located between parallel lines are equal to each other. And we also know that all the angles inside the rectangle are right angles. That is to say, this angle is a right angle, it equals to 90 degrees. This angle is also a right angle, that is to say it equals to 90 degrees. And this angle is also a right angle, that is to say it equals to 90 degrees. Okay? So, we know that AE equals to EF, AE equals to ED. AE equals to ED according to what is given us in the question. AE equals to ED. So if we define AE as X, then ED will be also equal to X, because they are equal to each other. And we also have the rule that the opposite sides of a rectangle are equal to each other. Side AD is located, side AD is the opposite sides of BC, therefore AD is equal to BC, but we know that AD equals to 2x, therefore BC will be also equal to 2x, according to the rule that the opposite sides of a rectangle are equal to each other. So if AD equals to 2x, then BC will be also equal to 2x. So we will focus on the right triangle, triangle BAE, the right green triangle, triangle BAE. On the right green triangle, triangle BAE, sinus theta equals to x over 7, and on the right lower right triangle, triangle BFC, on triangle BFC, sinus 2 theta sinus 2 theta equals to 2x over 9. I'll repeat again. On the right triangle, triangle BAE, sinus theta equals to x over 7, and on the right triangle, triangle BFC, on the right triangle, triangle BFC, sinus 2 theta equals to 2x over 9. We have the trigonometric identity that states that sinus 2 theta, it is algebraic, okay, according to the trigonometric identity, sinus 2 theta equals to 2 sinus theta, cosinus theta. I'll repeat again. We have the trigonometric identity that sinus 2 theta equals to 2 sinus theta cosinus theta. We know that according to equation number 2, sinus 2 theta equals to 2x over 9. That is to say, 2x over 9 equals to sinus 2 theta, and according to the trigonometric identity, the sinus 2 theta equals to 2 sinus theta cosinus theta, we will get that. So we will substitute here in equation number 2 sinus 2 theta by 2 sinus theta cosinus theta. They are equal to each other according to the trigonometric identity that I presented to you. So it equals to sinus 2 theta cosine theta. Again, 2x over 9 equals to 2 sine theta cosine theta. That is to say, we substituted sinus 2 theta by 2 sinus theta cosine theta. So we got that we got that 2x over 9 equals to sine 2 theta, and we substituted sine 2 theta by 2 sine theta cosine theta because according to the trigonometric identity they are equal to each other. We have already found out that sine theta equals to x over 7. Sine theta equals to x over 7 times cosine theta, and it equals to 2x over 9. So here we have 2x on both sides of equation number 2, so 2x will get cancelled, and we got that 1 over 9 equals to cosine theta over 7. We will multiply equation number 2 by 7, and we will get that cosine theta equals to 7 over 9. Cosine theta equals to 7 over 9. But cosine theta, the function cosine theta, it actually defines the relationship between the sides of a right angle, between the side that is near the side angle theta over the hypotenuse. So we can draw the function cosine theta equals to 7 over 9. It will be a right triangle with hypotenuse, with the hypotenuse that equals to 9 units, and the side that is near angle theta will be equal to 7 units. So this drawing describes the function that cosine theta equals to 7 over 9. Okay. What is the value of this side? What is the value of the side that is in front of angle theta? If we define it as S, then 9 square, according to the Pythagoras theorem, will be equal to 7 square plus S square. That is to say, S square equals to 9 square minus 7 square. That is to say, S equals to the square root of 9 square minus 7 square. That is to say, S equals to the square root of 9 square is 81 minus 7 square is 49. That is to say, S equals to the square root of 81 minus 39. 81 minus 49 equals to 42. So the square root of 42, the square root of 32, it is actually equals to 16 times 2. 32 equals to 16 times 2, and the square root of 16 is 4. So in total, we found out, in conclusion, we found out that S equals to 4 times square root of 2. So in conclusion, we actually found out that cosine theta equals to 7 over 9, and sine theta equals to 4 times square root of 2 over the hypotenuse, that is 9. I'll repeat again. In conclusion, we found out that cosine theta equals to 7 over 9, while sine theta equals to 4 times square root of 2 over 9. So we return to our drawing. In the right triangle, triangle ABE. In the right triangle, triangle ABE. This angle is theta. This is the right angle. This is BAE. This is X. So this is the right triangle, triangle ABE. Here we know that sine theta equals to X and BE is 7 units over 7. Sine theta equals to X over 7. But we have already found out that sine theta equals to 4 times square root of 2 over 9. It equals to X over 7. We will multiply this equation by 7, and we will get that X equals to 7 times 4 is 28 times square root of 2 over 9. So we found out that X equals to 28 times square root of 2 over 9. So we can write here that X equals to 28 times square root of 2 over 9. Here it is also X, it equals to 28 times square root of 2 over 9. Therefore, 2X will be equal to 28 times 2 is 56 times square root of 2 over 9. And we know that the opposite sides of a rectangle are equal to each other. That is to say, BC equals to AD. So if BC equals to AD, and we know that BC equals to 56 times square root of 2 over 9, then AD will be also equal to 56 times square root of 2 over 9. And here cosine theta, if we focus on the right triangle, triangle ABE, cosine theta equals to AB over 7, but we have already found out that cosine theta equals to 7 over 9, so 7 over 9 equals to AB over 7. We will multiply this equation by 7, and we will get that AB equals to 7 times 7 is 49 over 9. AB equals to 49 over 9. AB equals to 49 over 9. So we can write here that AB equals to 49 over 9. Okay. In the next step, we will focus on the right triangle, triangle BFC. On the right triangle, triangle BFC, according to the Pythagoras theorem, on the right triangle, triangle BFC, according to the Pythagoras theorem, cosine 2 theta equals to, here it is C, equals to FC over 9 it is not Pythagoras theorem, but it is the function of cosine. Cosine 2 theta equals to FC over 9. We will multiply this equation by 9 and we will get that FC equals to 9 times cosine 2 theta. FC equals to 9 times cosine 2 theta, and we have the trigonometric identity that states that cosine 2 theta equals to 2 times cosine square theta minus 1. We will substitute cosine 2 theta in this equation by 2 times cosine theta square minus 1 that equals to it, and we will get that FC equals to 9 times cosine theta according to this trigonometric identity equals to 2 times cosine square theta minus 1. Okay. We got that FC equals to 9 times 2 cosine square theta minus 1. We have already found out that cosine theta equals to 7 over 9. So FC will be equal to 9 times 2, and cosine theta equals to 7 over 9, therefore cosine square theta will be equal to 7 over 9 square minus 1. So we found out that FC equals to 9 times 2 times 7 over 9 square minus 1. 7 over 9 square is 7 square over 9 square, that is to say 49 over 81. So I write it down. We found out that FC equals to 9 times 2 times 49 over 81, and we will substitute 1 or minus 1 by minus 81 over 81, so it will be 81, and 2 times 49 is 98, so FC equals to 9 times 98 minus 81 over 81. Okay, we found out that FC, here it is 81, FC equals to 9 times 98 minus 81 over 81. We will divide this equation by 9 and we will get that FC equals to 98 minus 81. 81 over 9 is 9. So in conclusion, we got that FC equals to 98 minus 21 over 9. 98 minus 21 is 17, so I write it down. So we actually found out that FC equals to 17 over 9 units. FC equals to 17 over 9 units, so we can write here that FC equals to 17 over 9 units. And we know that the opposite sides of a rectangle are equal to each other. That is to say, AB is equal to DC. So if AB equals to 49 over 9, then DC will be also equal to 49 over 9. DC equals to 49 over 9. And DC minus FC equals to DF. You can see it from the drawing that DC minus FC equals to DF. DC minus FC equals to DF. I'll repeat again. From the drawing you can see that DF equals to DC minus FC. That is to say, DF equals to DC. DC is 49 over 9 minus FC. FC is 17 over 9. So in conclusion, we found out that df equals to 49 over 9 minus 17 over 9. 49 minus 17 is 32. So in conclusion, we found out that df equals to 32 over 9. 32 over 9. So right here the df equals to 32 over 9. df equals to 32 over 9. So actually, because of the fact that we know all the sides, the lengths of all the sides of trapeze ABFD, we can easily calculate the area of the green trapeze. So the area of the green trapeze ABDF will be equal to the sum of its sides, that is to say AB plus DF, times the height, that is AD, over 2. I will repeat again. The area of trapeze ABDF equals to the sum of its sides, that is to say AB plus DF, times the height, that is AD, over 2. So the area of trapeze ABDF will be equal to AB. We've already found out that AB equals to 49 over 9 plus DF. We already found out that DF equals to 39 over 32 over 9 times the height AD equals to 56 times square root of 2 over 9 all divided by 2. So the area of trapeze ABDF equals to this expression. 49 plus 32 is 81, so I write it down. The area of trapeze ABDF, that is the area of the green shape, equals to 81 over 9 times 9 times 56 times square root of 2 over 2. So here 9 times 9 is 81. 81 over 81 is 1, so this is cancelled. So we found out that the area of the green shape equals to 56 over 2 times square root of 2 units, that is to say it equals to 28 times square root of 2 square units, or in terms of numbers it equals to 39.6 square units. I repeat again, we found out that the area of trapeze ABDF for the green shape, that is actually also the green shape, it equals to either to 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay, so we finished with the second method. So we will start with the third method. In the third method, we will draw perpendicular from point E to BF. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, because this is perpendicular from point E. We will define the touching point between the perpendicular and BF as point M. We know that all the angles inside a rectangle are right angles, so this angle is a right angle, that is to say it equals to 90 degrees. This angle, it is also a right angle, that is to say it equals to 90 degrees, and this angle also is a right angle, that is to say it equals to 90 degrees. Okay, so we will focus on those two right angles, and we will prove that those two right angles congruent to each other. That is to say, we will prove that the right triangle ABE, this right green triangle ABE, is congruent to the right triangle BEM. Okay? First of all, it is given us in the question that those two angles, they are equal to each other, they are both equal to theta. That is to say, angle ABE from triangle ABE is equal to angle EBM from triangle EBM, and those both angles, they are both equal to theta. I'll repeat again. Angle ABE equals to angle EBM, and they are both equal to theta according to what is given us in the question. We also know that those two angles, they are right angles, therefore they are equal to each other. That is to say, angle BAE equals to angle BMF in this green triangle, and they are both equal to 90 degrees. I'll repeat again. Angle BAE equals to angle BME. They are both equal to 90 degrees. They are right angles. And those two angles, they are equal to each other according to third angle theorem. So this angle, that is actually angle AEB, equals to this angle, that is actually angle BEM, and and they are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. Okay, we found that those two angles in this great triangle congruent to those two angles in this triangle. Therefore, the third pair of angles must also congruent, that is to say, they are equal to each other according to third angle theorem. Therefore, as we also have here, BE equals to BE is a common side. BE equals to BE is a common side that belongs to both triangles. I'll repeat again here. Angle AEB equals to BEM according to third angle theorem, and BE equals to BE. It is a common side that belongs to both triangles. So we actually proved that those two triangles congruent to each other according to angle side angle rule. I will not repeat on what is angle side angle rule because I explained it in the previous method. So triangle ABE is congruent to triangle BEM according to angle side angle rule. I'll repeat again. Triangle ABE is congruent to triangle BEM according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that side AB of triangle AEB equals to side BM of triangle EBM. Again, AB equals to BM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides will be equal to each other, that is to say AB will be equal to BM. Okay? And if we define AB as Y, so AB equals to Y, from this equality we will conclude that BM also equals to Y. So BM equals to Y. Likewise, from the fact that those two triangles congruent to each other, we will conclude that AE equals to EM. AE equals to EM. AE equals to EM according to the rule that corresponding sides in congruent triangles are equal to each other. And if we define AE as X, then we know that AE equals to ED, therefore ED will be also equal to X. And AE equals to X, so EM will be also equal to X. Okay, and you can see it also from this equality that if AE equals to X, then EM also equals to X. Okay. We know that BAF equals to 9 units according to what is given us in the question. If BF equals to 9 units, then MF equals to BF minus BM. Again, BF minus BM equals to MF. That is to say, MF will be equal to 9 minus Y units. Very simple. You can see it from the drawing. Okay. BF minus BM equals to MF. That is to say 9 minus Y equals to MF. Okay, in the next step we will join points E and F together by a straight line. And we will prove that those two right triangles can go into each other. That is to say, triangle EDF, the right triangle EDF, can go into the right triangle EMF. We'll repeat again. We will prove that the right triangle EDF can go into the right triangle EMF. First of all, we have those two angles are right angles, therefore they are equal to each other. That is to say, angle EMF equals to angle FDE. And both those two angles are right angles, that is to say they are equal to 90 degrees. Again, angle EMF equals to angle FDE. They are both equal to 90 degrees, they are right angles. We have already found out that EM equals to ED, then they are both equals to X units according to our definition. EM equals to ED, and they are both equal to X units according to our definition. So EM equals to ED equals to X. And EF is a common side, it belongs to both triangles. So EF equals to EF is a common side that belongs to both triangles. EF equals to EF. It's a common side that belongs to both triangles. I'll repeat again. EF equals to EF is a common side that belongs to both triangles. So actually, in this way, by proving those three equalities, we actually, because of the fact that we are talking about right triangles, we actually proved that those two triangles can go into each other. So I write it down. We proved the triangle EDF congruent to triangle EMF. Then we proved the triangle EDF congruent to triangle EMF according to the following rule. According to rule number 5, rule number 5 says that if the hypotenuse and a perpendicular in two right triangles congruent, then the right triangles congruent to each other. I repeat again on rule number 5. According to rule number 5, if the hypotenuse and the perpendicular in two right triangles congruent, then the right triangles congruent to each other. And we actually proved that the hypotenuse EF and the perpendicular EM in the right triangle EMF congruent to the hypotenuse EF and the perpendicular ED in the right triangle EDF. Therefore, we proved that those two right triangles congruent to each other according to rule number 5. Okay? And from the fact that those two right triangles congruent to each other, we will conclude that MF equals to FD. MF equals to FD. MF in triangle EMF equals to FD in triangle EDF. MF equals to FD according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore those two corresponding sides will be equal to each other. But we have already found out that MF equals to 9 minus Y. MF equals to 9 minus Y. So from this equality we will conclude that FD also equals to 9 minus Y. 9 minus Y. FD equals to 9 minus Y. FD or DF equals to 9 minus Y. But we know that the opposite sides of a rectangle are equal to each other. That is to say, AB equals to CD. If AB equals to CD and AB equals to Y units, then CD will be also equal to Y units. Okay, CD will be also equal to Y units. So we know that CD equals to Y units and DF equals to 9 minus Y. So what is FC? FC equals to CD minus DF. Okay, it is very easy to see that from the drawing that DC minus DF equals to FC. DC minus DF equals to FC. I'll repeat again. You can easily see that for the drawing that DC minus DF equals to FC. DC equals to Y minus DF equals to 9 minus Y. So the FC equals to DC, that is Y, minus FC, that is 9 minus Y. That is to say FC equals to Y minus 9 minus Y is plus Y. In conclusion, we found out that FC equals to Y plus Y is 2Y minus 9. 2Y minus 9. So FC equals to 2Y minus 9. And again, we know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to BC. AD equals to x plus x. That is to say, AD equals to 2x. Therefore, BC will be also equal to 2x. Okay. In the next step, we will focus on the right triangle, triangle ABE. Right triangle, triangle ABE. In the right triangle ABE. In the right triangle ABE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BE. So BE square equals to BA square plus AE square. Okay. BE is 7, so BE square is 7 squared. 7 squared is 49. Equals to BA square. BA is Y, so BA square is Y square. Plus AE square. AE is X, so AE square is X square. So according to equation number 1, X square plus Y square equals to 49. In the next step, we will focus on the right triangle, triangle BFC. On the right triangle BFC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BF, and BF can see BF equals to 9 units. It is given us in the question. So BF square is 9 square. BF square is 9 square. 9 square is 81. It equals to BC square. That is actually BC equals to 2x, so BC square is 2x square. 2x square is 4x square plus FC square. FC square is 2y minus 9 square. 2y minus 9 square. So in conclusion, we found out that according to the Pythagoras theorem, in the right triangle, triangle BFC, 81 equals to 4x squared plus 2y minus 9 squared. We'll open the brackets on the second in this side of equation number 2, and we will get that 81 equals to 4x squared plus 2y minus 9 squared is 4y squared plus 81 minus 36y. Here we have 81 on both sides of equation number 2, so 81 will get cancelled. So 0 equals to, we'll take a common factor 4 from these two expressions, and we will get 81 equals to 4 times x squared plus y squared minus 36y. According to equation number 1, x squared plus y squared equals to 49. So we will substitute x squared plus y squared in equation number 2 by 49 from equation number 1, and we will get that 0 equals to 4 times x squared plus y squared is 49 minus 36y. We will add to this equation number 2, 36y, and we will get that 36y equals to 4 times 49. We will divide this equation number 2 by 4, and we will get that 9y equals to 49. We got, according to equation number 2, 9y equals to 49. We will divide this equation number 2 by 9, and we will get that y equals to 49 over 9. And according to equation number 1, x squared plus y squared equals to 49. And according to equation number 2, y equals to 49 over 9. So we substitute y in equation number 1 by 49 over 9, and we will get that x squared plus y is 49 over 9. 49 over 9, yes. 49 over 9 square equals to 49. We will subtract 49 over 9 square from this equation number 1, and we will get that x squared equals to 49 minus 49 over 9 square. We know that 49 equals to 7 square. So we substitute 49 by 7 square, and we will get that x squared equals to 7 square minus 49 over 9 square. We have the trigonometric identity, the algebraic identity that a squared minus b squared equals to a plus b minus b. Again, according to the trigonometric identity that a squared minus b squared equals to a plus b times a minus b, here b squared is 0, b squared is 0, a equals to 7, and b equals to 49 over 9. So according to this trigonometric identity, we will get that x squared equals to 7 plus 49 over 9 times 7 minus 49 over 9. We will divide 7 by 9 and then we will multiply it by 9 in order to have a common factor with this expression, and we will get that x squared equals to 63 plus 49 over 9 times 63 minus 49 over 9. So we got that x squared according to equation number 1 equals to 63 plus 49 is 112 over 9. 63 minus 49 is 14 over 9. So in conclusion, we found out that x squared equals to 112 times 14 over 9 times 9. 112 is 12 times 8, so I write it down. We'll get that x squared equals to 8 times 14 times 14 over 9 times 9. So x squared equals to 8 is 2 times 2 times 2, so I write it down, 2 times 2 times 2 times 14 times 14 over 9 times 9. Here we will take a root out of this equation, equation number 2, and we will get that x equals to the square root of 2 times 2 times 2 times 14 times 14 over 9 times 9. So actually we found out that according to equation number 1, x equals to the square root of 14 times 14 is 14, and the square root of 2 times 2 is 2, so it, in conclusion it's 2 times 14, and the square root of 9 times 9 is 9, and the only number that is inside the root is 2. So in conclusion, we found out that x equals to 2 times 14 times square root of 2 over 9, and y equals to 49 over 9. 2 times 14 is 28, so I write it down. So actually x, according to equation number 1, equals to 28 times square root of 2 over 9, and y equals to 49 over 9, and the area of the green trapeze ABFD equals to AB plus DF times AD over 2. I'll repeat again, the area of the green trapeze equals to AB plus DF times AD, that is the height, over 2. So AB so the area of trapeze ABDF, ABFD equals to AB. AB is Y, and Y is 49 over 9. Now DF, that is no, actually the area of trapeze ABDF is equals to AB is Y minus DF plus DF, that is actually 9 minus Y. Again, it equals to AB is Y and DF is 9 minus Y times AD. AD equals to 2x over 2. Okay, so the area of trapeze ABFD equals to Y minus Y is 0. So in conclusion, the area of trapeze, the green shape ABFD, equals to 9, 2 over 2 is 1, it equals to 9x. And we have already found out that x equals to 28 times square root of 2 over 9. 9 over 9 is 1, so in conclusion we found out that the area of trapeze ABFD, or the green shape, equals to either 28 times square root of 2 square units or in terms of numbers it equals to 39.6 square units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the area of the green trapeze or the green shape ABDF. In the first method, we extended 9 segment BE and 9 segment CD until they intersect with each other at point P. Then I presented to you rule. Actually, we know that CD is one side of rectangle ABCD, therefore it is a straight line. And when we extended the straight line CD by a straight line, it will still remain a straight line. Therefore CP is a straight line, CP is a straight line, and we have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line CP at point D, then the sum of the angles at point D on this side of the straight line CP must be equal to 180 degrees. So which angles we have at point D on this side of point D? We have this angle that is x plus this angle that is 90 degrees, and the sum of them must be equal to 180 degrees according to rule number 1. So x plus 90 degrees must be equal to 180 degrees according to rule number 1. We subtracted 90 degrees from this equality and we got that angle x equals to 90 degrees. So we found out that this angle is a right angle, that is to say it equals to 90 degrees. Then we know that AB is parallel to CD. AB is parallel to CP. AB is parallel to CP because of the fact that the opposite sides of a rectangle are parallel to each other, and if AB is parallel to CD, then AB will be also parallel to CP, because CP is just an extension of CD by a straight line, so it will be still the same CD, therefore AB will be also parallel to CP, because CD and P are on the same straight line. Therefore, if AB is parallel to CD, then AB must be also parallel to CP. And we have also rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. And because of the fact that AB is parallel to CP, those two alternating angles must be equal to each other according to rule number 2. That is to say, angle ABE must be equal to angle EPD. But we know that angle ABE equals to theta. Angle ABE equals to theta. So from this equality we will conclude that angle ABD also equals to theta. So this angle equals to theta. Then we proved that those two right triangles can go into each other. Why? Because angle BAC equals to angle EPD equals to theta. Those two angles, they are equal to each other, they are both equal to theta. We also know that those two angles, they are right angles, therefore they are equal to each other. And those two angles, they are equal to each other according to the rule that vertex angles are equal to each other. And it is given us in the question that AE equals to ED. Okay, according to it is given us in the question, therefore triangle BAE is congruent to triangle PED according to angle side angle rule. And what is angle side angle rule? Angle side angle rule is that if two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included between those two angles in another triangle, then the triangles can go into each other according to angle side angle rule. Okay, and we proved that those two angles and the side that include between them this side in triangle PED congruent to those two angles, and the side that included between them, that is to say AE, in the green triangle. Therefore, proved that those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude that EB equals to EP, EB equals to EP according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding sides will be equal to each other. But we know that EB equals to 7 units, and from this equality we will conclude that EP also equals to 7 units. And then we defined the area of quadrilateral EDFB SY, BEFD SY, the area of quadrilateral BE or BFED SY, and we define the area of the green right triangle AEB as X. So we have to find out the area of the green shape that is actually equals to X plus Y. We have to find out the value of X plus Y, but because of the fact that those two triangles can go into each other, they also have the same area. So if the area of the green triangle equals to X, then the area of triangle BDC that can go into it will be also equals to X. So if we will find out the area of triangle PBF that equals to X plus Y, we will find out the area of the green shape that also equals to X plus Y. So we will find out the area of triangle PBF. Okay, we will find out the area of triangle BPF that equals to X plus Y. We know that triangle BPF is an isosceles triangle. Why? Because it has two angles, they are equal to each other, they are both equal to theta, and we have rule number 3. According to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have isosceles triangle, triangle ABC is an isosceles triangle. Why? Because it has two angles that are equal to each other, they are both equal to theta, therefore triangle ABC is an isosceles triangle. And the median AO bisects the base BC. And according to rule number 3, the median in an isosceles triangle to the base is perpendicular to the base. That is to say, AO is perpendicular to BC. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. We will implement rule number 3 in the isosceles triangle PBF. The isosceles triangle PBF, the base is PB, so the median FE to the base PB, it is not only bisects the base to two equal parts, that is to say PE equals to EB, they are both equal to 7 units, but it is also perpendicular to the base, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. And because of the fact that this angle equals to 90 degrees, then triangle EBF is a right triangle. So we can implement the Pythagoras theorem in this right triangle. Triangle EFB. So according to the Pythagoras theorem, in the right triangle, triangle EFB, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BF, so the square of the hypotenuse is BF squared, and it equals to BE squared plus EB squared. EB equals to 9 units, so EB squared is 9 squared is 81. And it is actually BF. BF equals to 9 units, therefore BF squared is 9 squared, 9 squared is 81. BE equals to 7 units, 7 squared is 49. So BE squared is 49 plus EF squared. So we got that 81 equals to 49 plus EF squared. We subtracted 49 from this equation, equation number 1, and we got that 81 minus 49 is 32. So in conclusion, we found out that 32 equals to EF squared. We took a root out of this equation, equation number 1, and we got that EF equals to the square root of 32. 32 is 16 times 2. So, and the square root of 16 is 4. So in conclusion, we found out that EF equals to 4 times square root of 2. EF, so the height, EF equals to 4 times square root of 2, and the base is 7 plus 7, that is to say it equals to 14 units. And the base times the height to the base is the over 2 is the area of triangle PBF. The area of triangle BPF equals to the base of the triangle times the height to the base over 2, and the base is PB, and the height to the base is EF over 2. EF equals to 14 units, BP, that is the base, equals to 14 units, EF equals to 4 times square root of 2 units. So in conclusion, the area of triangle BPF equals to 14 times 4 times square root of 2 over 2. 14 over 2 is 7, so in conclusion we found out that the area of triangle BPF equals to 7 times 4 times square root of 2. 7 times 4 is 28, so in conclusion we found out that the area of triangle BPF, that is also equals to the green shape, it equals to 28 times square root of 2 square units, so in terms of numbers, it equals to 49.6 square units. Okay, so we finished with the first method. Then I presented to you the second method. The second method was, in the second method, we actually know that AB in rectangle ABCD, AB is parallel to DC because of the fact that the opposite sides of a rectangle are parallel to each other. So if AB is parallel to DC, AB will be also parallel to part of DC, this is to say AB is parallel to FC. And because of the fact that AB is parallel to CF, so those two angles are located between the parallel lines AB and FC, therefore they are equal to each other. So if this angle is 2 theta, then this angle will be also equal to 2 theta according to the rule that I have already mentioned. Okay, so we found out that this angle equals to 2 theta, and all the angles inside the square rectangle are right angles. This angle is right angle, and those two angles are also right angles. So in the right triangle ABE, we know that sinus theta equals to x over 7. Sinus theta equals to x over 7. And in the right triangle BCF, sinus 2 theta equals to 2x over 9. Sinus 2 theta equals to 2x over 9. Okay, So we have equation number 1 states that sinus theta equals to x over 7, and the equation number 2 states that sinus 2 theta equals to 2x over 2. But according to the trigonometric identity that sinus 2 theta equals to 2 sinus theta cosine theta, we can substitute sinus 2 theta by this expression. You know that sinus 2 theta equals to 2 sinus theta cosinus theta. So we can substitute sinus 2 theta by 2 sin theta cosine theta. And we have already found out that sin 2 theta equals to 2x over 9. So we substituted sinus 2 theta by this expression. And we got this expression here. We know that sin theta according to equation number 1 equals to x over 7. So we substituted sin theta by x over 7. In conclusion, we found out that 2x over 9 equals to 2x over 7 times cosine theta. We have 2x on both sides of equation number 2, so 2x will get cancelled. We left with 1 over 9 equals to cosine theta over 7. We multiplied this equation number 2 by 7, and we found out that cosine theta equals to 7 over 9. Cosine theta equals to 7 over 9. But the function cosine is the relationship between the sides of a right triangle. So cosine theta equals to 7 over 9. If we draw this function, it means that we have a right triangle with angle theta. The hypotenuse equals to 9 units, and the side that is near angle theta equals to 7 units. So we will find the missing side. We define it as x. According to the Pythagoras theorem, 9 square plus s square. According to the Pythagoras theorem, 7 square plus s square equals to 9 square. Here we subtracted 7 square from this equality. We got that s square equals to 9 square minus 7 square. So s equals to square root of 9 square minus 7 square. That is to say, s equals to 9 square is 81 minus 7 square is 49. So 81 minus 49 is 32. So we found out that s equals to the square root of 32. 32 is 16 times 2, that is to say, and the square root of 16 is 4. So we found out that s equals to 4 times square root of 2 units. So s equals to 4 times square root of 2 units. Therefore, sinus theta will be equal to 4 times square root of 2 units over 9. Okay. Here, sinus theta will be equal to 4 times square root of 2 units over 9, and we already found out that cosine theta equals to 7 over 9. Okay. I draw again the right triangle ABE. We know that A equals to x, EB equals to 7 units. This angle is angle theta. So sin theta equals to x over 7. But we have already found out that sin theta equals to 4 times square root of 2 over 9. So we can substitute sin theta by this expression. And we got that 4 times square root of 2 over 9 equals to x over 7. We multiplied this equation by 7, and we found out that x equals to 28 times square root of 2 over 9. X equals to 28 times square root of 2 over 9. This is also x is also equals to 28 times square root of 2 over 9. So if x equals to 28 times square root of 2 over 9, then 2x will be equal to 56 times square root of 2 over 9. That is to say BC equals to 56 times square root of 2 over 9, and this is also the size of the length of AD. And then here we implemented we know that cosine theta equals to AB over 7. Cosine theta equals to AB over 7. You can see here cosine theta equals to AB over 7. But we know that cosine theta equals to 7 over 9, so we can substitute cosine theta by 7 over 9. So we got that 7 over 9 equals to AB over 7. We multiplied this equation by 7 and we found out that AB equals to 49 over 9. So here AB equals to 49 over 9. We also know that AD equals to 56 times square root of 2 over 9. And we only need to find out the value of DF in order to find out the area of trapeze ABDF. So then we focused on this right triangle, triangle BFC or FCB. In the right triangle FCB, cosine 2 theta equals to FC over 9. Cosine 2 theta equals to FC over 9, the hypotenuse. We multiplied this equation by 9 and we got that FC equals to 9 times cosine 2 theta. And according to the trigonometric identity, that cosine 2 theta equals to 2 cosine square theta minus 1. So we can substitute cosine 2 theta by this expression. So we did it and we found out that FC equals to 9 times 2 times cosine square theta minus 1. Okay? And we know that cosine theta equals to 7 over 9. Okay? We know that cosine theta equals to 7 over 9. Therefore, FC will be equal to 9 times cosine square theta is 7 over 9 square minus 1. So FC equals to 9 times 2. 7 square is 49. 9 square is 81. Minus 1 is 81 over 81. So in conclusion, we got this equality. We divided this equation by 9. Actually, we know that 2 times 49 is 98. So in conclusion, we found out that FC equals to 9 times 28 minus 81 over 81. We divided this equation by 9 and we got that FC equals to here 81 over 9 is 9. So in conclusion, we found out that FC equals to 98 minus 81 over 9. That is to say FC equals to 17 over 9. Okay, we found out that FC equals to 17 over 9. So what is the value of DF? DF equals to CD minus CF. Okay. DF equals to CD or DC minus FC. So DF equals to CD is 49 over 9 and FC is 17 over 9. So in conclusion, we found out that DF equals to 32 over 9. We found out the value of DF, that is 32 over 9. So we have all the sides of trapeze ABFD, so we can easily find out the area of the green trapeze. The area of trapeze ABDF equals to the sum of its sides, that is to say AB plus DF times the height AD over 2, so it is AB plus DF times the height AD over 2. AB is 49 over 9, plus DF is 32 over 9, times the height AD is 56 times square root of 2 over 9. So here 49 plus 32 is 81. So it is 81 over 9 times 9. So here we have 81 over 9 times 9. This is actually 81 over 81 is 1. So these two expressions cancelled. And we left only with that the area of trapeze ABDF equals to 56 over 2 times square root of 2. That is to say, the area of trapeze, the green trapeze ABDF equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 32.6 square units. So we finished with the second method. Then I presented to you the third method. In the third method, we actually drew perpendicular from point E to BF, and we defined the touching point between the perpendicular and BF as point M. So this is perpendicular, so that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Then we know that all the angles inside a rectangle are right angles, so those 1, 2, 3 angles are right angles, and we proved that those two right triangles can go into each other. Okay, so actually I'll repeat again, we proved that those two triangles can go into each other. That is to say, we proved that triangle ABE can go into triangle BEM. Why? Because first of all, we know that those two angles, they are both equal to theta, therefore they are equal to each other. That is to say, angle ABE equals to angle EBM equals to theta. And those two angles, they are both right angles, therefore they are equal to each other. That is to say, angle BAE equals to angle BMF equals to 90 degrees. And those two angles are also equal to each other according to third-angle theorem. What is third-angle theorem? According to third-angle theorem, if two angles in one triangle can join to two angles in another triangle, then the third pair of angles must also congruent. So we proved that those two angles in right triangle EBM congruent to those two angles in the right triangle ABE. Therefore, those first pair of angles must also congruent according to third-angle theorem. Therefore, we proved that all the angles of those two right triangles congruent. And we also have here the common side. EB equals to EB is a common side, and we actually proved that triangle ABE is congruent to triangle BEM according to angle side angle rule. I will already explain to you what is angle side angle rule. From the fact that those two triangles congruent to each other, we will conclude that AB equals to BM. AB equals to BM, and if we define AB as Y, then BM will be also equal to Y. This equality considered BM also equals to Y, so AB equals to Y and BM equals to Y. And we also can conclude that AE equals to EM, AE equals to EM. So if we define AE as X, then AE equals to EM equals to X, so EM will be also equal to X. But we also know that AE equals to ED. It is given us in the question that AE equals to ED. Therefore, if AE equals to X, then ED will be also equals to X. So we have three sides that are equal to X. So we found out that AB equals to BM equals to Y, and AE equals to EM. They are both equal to X. Then we connected together points. We joined together points E and M by a straight line, and we proved that those two right triangles can go into each other. So we proved that triangle EDF can go into triangle EMF. Why they can go into each other? First of all, we have those two right triangles that are equal to each other. That is to say, angle EMF equals to angle EDF equals to 90 degrees. And ED equals to EM equals to X. We have already proved they're equal to each other and they're both equal to X. And EF equals to F is a common side that belongs to both triangles. So we actually proved that triangle EDF can go into triangle EMF. Why they can go into each other? They can go into each other according to rule number 5 that says that if the hypotenuse and the perpendicular in two right triangles can go in, then the right triangles can go into each other. And we actually proved that the hypotenuse EF and the perpendicular EX in the right triangle EDF can go into the hypotenuse EF and the perpendicular EM in the right triangle EMF. Therefore, we proved that those two right triangles can go into each other according to rule number 5. And from the fact that they can go into each other, we will conclude that MF equals to FD. MF equals to FD according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides MF and FD will be also equal to each other. But we know, so MF equals to FD. Okay, but we know that MF equals to 9 minus Y. And from this equality we will get that FD will be also equal to 9 minus Y. Okay, and then we know that BF equals to 9 units and BM equals to Y, therefore MF will be equal to BF minus BM, that is to say MF equals to BF, that is 9, minus BM, that is Y. That is to say, MF equals to 9 minus Y. Okay, DC minus DF equals to FC. And then, so MF equals to 9 minus Y. And when we have already found out that DF equals to 9 minus Y, and DC equals to AB, that equals to Y. So DC equals to Y. DF equals to 9 minus Y. So CF equals to DC minus DF. Okay? FC equals to DC minus DF. FC equals to DC minus DF. So FC equals to DC, that is Y, minus DF, that is 9 minus Y. So FC equals to Y minus 9 minus Y, that is to say FC equals to Y minus Y is 2Y. So in conclusion, we found out that FC equals to 2Y minus 9, FC equals to 2Y minus 9. Okay? And we know that AD equals to BC and AD equals to 2x, therefore BC will be also equal to 2x, according to the rule that the opposite sides of a rectangle are equal to each other. Then we focus on the right triangle, triangle AEB. According to the Pythagoras theorem, EB square equals to AE square plus AB square, BE square equals to BA square plus AE square. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. BE equals to 7, so BE square equals to 7 square is 49, equals to BA is Y, so BA square is Y square, plus AE square. AE is X, so AE square is X square. So in conclusion, we found out that according to equation number 1, X square plus Y square equals to 49. Then we focus on the right triangle, triangle BFC. On the right triangle, triangle BFC, According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is FB that equals to 9. Therefore, the square of the hypotenuse is 9 square. 9 square is 81. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to FC square plus BC square. FC is 2x, so FC square is 4x square. And actually BC is 2x, so BC square is 2x square, this is 4x square. And CF is 2y minus 9, so CF square is 2y minus 9 square. Okay, so in conclusion, we found out that in the right triangle BFC, 81 equals to 4x square plus 2y minus y square. We open the brackets on this side of equation number 2, and we found out that 81 equals to 4x square plus 4y square plus 81 minus 36y. We have 81 in both sides of equation number 2, so 81 will get cancelled. In conclusion, we found out that 0 equals to 4. We took a common factor of 4 from these two expressions, and we got that 0 equals to 4 times x squared plus y squared minus 36y. But according to equation number 1, x squared plus y squared equals to 49. So we can substitute x squared plus y squared from equation number 2 by 49 from equation number 2. By 49 from equation number 1. So we did it, and we got that 0 equals to 4 times 49 minus 36y. So we added 36y to this equation number 2, and we found out that 36y equals to 4 times 49. We divided this equation by 4, and we got that 9y equals to 49. We divided this equation number 2 by 9, and we got that y equals to 49 over 9 according to equation number 2, and according to equation number 1, x squared plus y squared equals to 49. So x squared plus y squared, and y equals to 49 over 9, so y squared will be equal to 49 over 9 squared equals to 49. So x squared, we subtracted 49 over 9 squared from this equation number 1, and we got that x squared equals to 49 minus 49 over 9 squared. 49 is 7 squared. So in conclusion, we got that x squared equals to 7 squared minus 49 over 9 squared. We use the algebraic identity that a squared minus b squared equals to a plus b, a minus b. And here b squared is 0, and a equals to 7, and b equals to 49 over 9. So in conclusion, we got that according to this trigonometric identity, x squared equals to 7 plus 49 over 9 times 7 minus 49 over 9. We multiplied 7 by 9, and then we divided by 9 in order to have a common factor with this expression. We found out that x squared equals to 63 plus 49 over 9 times 63 minus 49 over 9. 63 plus 49 is 112, and 63 minus 49 is 14. So in conclusion, we found out that x squared equals to 112 times 14 over 9 times 9. Here 112 is 14 times 8. So we substituted 112 by 8 times 14. And we got that x squared equals to 8 times 14 over 9 times 9. 8 is 2 times 2 times 2. So we substituted 8 by 2 times 2 times 2, and we got that x squared equals to 2 times 2 times 2 times 14 over 9 times 9. We took an root from this equation number 2, and we got that x squared, that the x equals to the square root of 2 times 2 times 2 times 14 over 9 times 9. The square root of 14 times 14 is 14. The square root of 2 times 2 is 2, and the square root of 9 times 9 is 9. So in conclusion, we found out that x equals to 2 times 14 times square root of 2 over 9. That is to say, 2 times 14 is 28. So x equals to 28 times square root of 14 over 9, and y equals to 49 over 9, and the area of triangle, the area of trapeze ABFD equals to the sum of its sides, that is to say AB plus DF times the height AD over 2. AB plus DF plus the height AD over 2. So actually we found out that the area of trapeze ABFD equals to AB is y, and DF is 9 minus y. So y plus 9 minus y, so AB plus DF is y plus 9 minus y times the height AD is 2x over 2. So in conclusion, we found out that the area of trapeze ABFD equals to 9 plus 9 minus y times 2x over 2. 2 over 2 is 1, y minus y is 0. So in conclusion, we found out that the area of trapeze ABEF equals to 2 times x. And x equals to 28 times square root of 2 over 9. 9 over 9 is 1, so in conclusion we found out that the area of trapeze ABFD equals to either 28 times square root of 2 square units, or in terms of numbers, the area of the green shape equals to 39.6 square units. Okay, thank you very much.